the latest news concerning Mars, and this picture has to do with the clouds on Mars. This is a NASA image, clouds on Mars, and various very strange geological formations. Now, thousands of ancient super-eruptions have been detected on Mars, according to geophysical research letters. This is on Science Alert. Now, if we think that Mars is an inhospitable place now, we're not wrong. It seems that the planet's current state is relatively mild and quiet in comparison to its distant past. Roughly 4 billion years ago, a region of the red planet called Arabia Terra experienced thousands of powerful and explosive volcanic super-eruptions. It filled the Mars atmosphere with so much dust and toxic gases that each one would have altered the Martian climate for decades at a time. These took place over a span of about 500 million years, meaning that early Mars, much like early Earth, was once a very different place from what it looks like today. Each one of these eruptions would have had a significant climate impact, of course. Maybe the released gas made the atmosphere thicker or blocked the sun and made the atmosphere colder. This is what geologist Patrick Welly of NASA's Goddard Space Flight Center explains to us. Kindly support my Patreon account since YouTube has again demonetized my YouTube channel. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below. He says modelers of Martian climate will have some work to do to try to understand the impact of the volcanoes on Mars' atmosphere. Super-eruptions are the most powerful of all known volcanic eruptions, with a magnitude of 8, the highest scale of the volcanic explosivity index. A supervolcanic eruption spews more than 1,000 cubic kilometers of material, that's 240 cubic miles, into the atmosphere and onto the surrounding terrain for up to thousands of kilometers. Although it was a long time ago that Arabia Terra of Mars experienced this activity, Welly and his team were able to uncover the evidence of the Martian surface from data recovered by the Mars Reconnaissance Orbiter's Compact Resonance Imaging Spectrometer for Mars, or CRISM for short. The terrain is an interesting one, pocketed with huge depressions that had been interpreted as impact craters. This is not unreasonable. Mars is covered with the things, but in 2013, papers suggested a different origin, not impact craters at all, but calderas. These are depressions left behind after a supervolcano has blown its stack, and once the magma is evacuated, the rock above has no structural support. It collapses into a sort of a huge sinkhole. Welly and his team were intrigued by this idea, but it can be hard to tell impact craters and calderas apart without looking at them more closely. So they looked for something else. The massive volume of volcanic ash that would have been deposited in these colossal eruptions. That 2013 paper had also modeled how much material should have been ejected. Another paper suggested that Arabia Terra terrain could contain ash deposits from ancient eruptions, and yet another worked out the effect of Martian atmosphere that would have had on ash dispersal. He says, we picked it up at the point and said, okay, well, these are minerals that are associated with altered volcanic ash, which has already been documented. So now we're going to look at how the minerals are distributed to see if they follow the pattern we would expect to see from super-eruptions. This is what volcanologist Alexandra Mateja Novak of Johns Hopkins Applied Physics Laboratory said. Because Arabia Terra is eroded to show layers of rock, the team took their volcanic mineral profile and started analyzing. They found layer deposits indicative and diagnostic of altered volcanic ash throughout that region. These include aluminum-dominant minerals such as montmorillonite, immogolite, and allophane. A three-dimensional topographic map of Arabia Terra then revealed how these minerals were layered. They were exactly where they were predicted to have fallen 4 to 3.5 billion years ago. And finally, the predicted volume of volcanic fallout allowed the team to figure out how many individual eruptions there had been, and it's huge. There were somewhere between 1,000 and 2,000 huge individual super-eruptions over 500 million years. That's amazing. The researchers estimate that over half a dozen supervolcanoes might manage this activity if each erupted every couple million years. This is really strange, the researcher said. Supervolcanoes here on Earth are not found in clusters like this. They appear in regions that include other types of volcanoes as well. And it's not like Mars only has one type of volcano either. So why should Arabia Terra appear so exclusively to host volcanic monsters? And why have we have not found any other supervolcanoes on Mars? People are going to read our paper and go, how could Mars do that? How can such a tiny planet melt enough rock to power thousands of super eruptions in one location? This is what geologist Jacob Richardson of NASA Goddard asks. He says, I hope these questions bring about a lot of other research. This is on Science Alert by Geophysical Research Letters. Please leave your comments and thank you for your support.